guys look at are 90, 180, 270, and 3 and 0. What's the point at 0? Anybody remember? Remember, this is a length of 1 right here. At 0. 1, 0. I'll give you that hint. I'm not going to give you any more, though. Okay, let's go. Go around the board for me. Here we go. Go around for me. Again, this painful 11. Who's got 11? Okay, what should it be at 90 then? That's 1, 0 at top here. This will be 0, 1. Keep going around here for me, Anna. At 180 now. Negative 1, 0, and at 270. 0, negative 1. Okay, those are really the only values I'm looking for. Questions on the unit circle before I move on? Okay, if you are on the unit circle, this is what we went over on Thursday as well. If you are on the unit circle, the x-coordinate is the cosine for x, and y-coordinate is sine. So what I'm going to do right now, let me just do, I'll go cosine of 60. Cosine of 60. Who's got number 6 in here? 6? Okay, Patrick. Cosine of 60. You see the coordinate at 60, right? If I'm going to find cosine, which coordinate do I pluck off? The y. No, just in y in general, not like y coordinate. I got you. I understood. Cosine is equal to the x coordinate. X coordinate at 60 is 1/2. Okay? Questions about that? And the other thing I tried to show you on Friday's video was if you're on the unit circle, we have this thing called the Pythagorean identity. And this is all it said. If you know sine, you can find cosine. If you have cosine, you can find sine using the Pythagorean identity, and you can plug in the numbers. I'll review one of those if you want from the assignment. Ask me, though, at the end, though. Okay, ask me in a couple minutes if you do have questions. But that's what that, if you're on, you got to be on the unit circle, though, to use the Pythagorean identity. Okay, got to be on the unit circle. And the big topic from Friday I wanted to get through to you guys was the following. Lucas, please pick any angle in the second quadrant. $110, fine. $110. If I ask you guys for the sine of 110 degrees, I have no idea what it's equal to, but you guys should be able to tell me if it's going to be positive or negative because it's in the second quadrant. What's that S stand for in the second quadrant? Anybody remember from Friday? What's the S stand for? I'm not looking for students either. Everything is positive in the first. The S stands for sine. The T for? Who's got 13? Okay, here we go. The S stood for what? Oh. What's the only thing really that starts with S we've been dealing with? Sine. You remember what the T stood for? How about the C then? Cosine, T's for tangent. Okay. What does that S mean? Sine is positive in the second quadrant, meaning this value is going to be something positive. What if I did cosine of 110? Cosine of 110. You can at least tell me it's going to be. Who's got 9? At least tell me it's going to be. What's that? At least tell me it's what? 2? Negative. Isabella, give me a angle in the third quadrant. 190. Tell me something you know about the cosine of 190. Cosine of 190. Here we go. Who's got 5? No 5? It's going to be negative. What about the sine of 190? It's going to be positive or negative. Sine of 190. What do we got? 6? Negative. Again, why? What's the only thing that's positive? Tangent. Okay? Everything else is negative. Cosine, positive in the fourth. Everything else negative. Okay? Go ahead. Start at any questions from either the packet, the assignment, if you tried anything, and I can't help you with you guys put in the effort to try some stuff. I can't help you with when it comes to Friday's test with that. Anything you want me to go over, either from the homework assignments Thursday, Friday night, or from the notes from Friday at all. Because we're going to start off today by reviewing, but still, I'll answer any of the questions that you have. Yep, go ahead, Reagan. Is that this one right here? Okay. Have your calculators out, pencils ready if you didn't try it. Here we go, pens, pencils out, calculator if you got one. I know it's math class. I don't know why we would bring one, but. What page is this, Reagan? So people, 29, thank you. Okay, use the Pythagorean identity. Here it is. Sine theta squared plus cosine theta squared equals 1. Now, you'll notice just a quick note. There's no theta in this problem. It's another Greek letter, beta. It's fine. It's an angle measure. All right, so if you want to substitute in beta, that's fine. What's this? Negative radical 3 over 3. What should I plug that in for? Who's got 14? Okay, let's go. 5. Okay, 13. All right, I'm done. Here we go. Isabella, let's go. I'm just going to go around the room. Eventually, everyone's going to get called on today, so you can't hide. Go ahead, Isabella. I put it in for sine. Thank you. So negative radical 3 over 3 squared. I just plug it in for the value of sine. And I'm solving for cosine. So that's what we get those nice calculators for. Negative radical 3 over 3, all squared. Go ahead. That's why we got those fraction templates. Not going to be a butler either. Ethan, what do you got? Negative radical 3 over 3 squared. Okay, can I get that a nice clean fraction, please? Because I'm not going to write all that. And it's negative. When you square a negative, you get a negative back. Yeah, you might want to put that in parentheses. So what do we end up getting? Get that 1/3 over. How do you want to move it over, Alex? You sure you want to multiply it? How am I going to move that over there? Subtract it over. Go ahead, everybody. Subtract it over. Subtract 1/3 on both sides. What do you end up getting, Matt, when you subtract it over? 2/3. Yep. Done there. Brooke, how am I going to get rid of that squared? How? Oh, yep. Sorry, you're right. Put it underneath the radical. That's how, and you already told me. Okay, so the squared's gone. I'm left with cosine theta. All right, I'll take over here because now here's where your algebra skills from last year take over. I don't know if you remember or not, but when you have a big square root, you can minimize it to 2 smaller ones over the numerator and the denominator. So these two exact same things. So I took the one big square root and put a square root over numerator and denominator. Hopefully we have a little bit more self-respect. What's wrong with that, Annika, right now? Can't have a radical in the denominator. How do I get rid of it, Patrick? And if some of you guys are wondering, why isn't he just going to the calculator? Simplest form, no decimals allowed. You guys should just be used to that anyway. No decimals allowed. Okay, here we go. Virginia, radical 2 times radical 3. I just multiply the numbers underneath. 2 times. Radical times itself, which I get underneath here. What's that? Radical 9, which is also known as square root of 9. Any more radical in the denominator? There you go. But we're not done yet. What usually happens when you take the square root of something? You're left with the plus and minus version, right? But, let's go back up top. Vinny, what quadrant am I working in? Quadrant 4. And you just found cosine in quadrant 4. A, S, T, C. I can only allow one of these for an answer. What do I know about cosine in the fourth quadrant? Cooper, cosine in the fourth quadrant, is it positive or negative? A, S, T, C. It is positive, so I'm only going to accept radical 6 over 3, the positive version. Do we see why I'm getting rid of the negative? Cosine is positive in the fourth quadrant. If it was negative, I'd leave the negative. So that's how I use that Pythagorean identity I was trying to show you on Friday. Reagan, we all right here? Okay, go to your packet now. It's time to review. Let's see where we are with all this. Should just be the next day. It says warm up at the top. Okay, Emily, ready? I'm given this equation, 6 sine x, find the value of f of 60. So this is telling me, where should I plug the 60 in for? Where's the 60 get plugged in? There's the equation, f of 60. So where do I plug the 60 in for? Okay, can you rewrite it now with the 60 plugged in? So this is going to equal 6. There you go. Thank you. So we're off to a good start there. Sine of 60. If you got to look back, look back. What is the coordinate on 60 on the unit circle? Okay, if you want to try to figure it out your own, I got a lot of respect for that. If not, just go back. It's not a big deal. What is the coordinate at 60 on the unit circle? Reagan, what do you got for me? What's the coordinate at 60? Thank you. Great job. But I am finding sine. So do I want the x or the y coordinate? Going back to you, Lucas. Do I want the x or the y coordinate if I'm looking for the sine? The y, what's the y coordinate up here? So 6 times radical 3 over 2. Everyone all right? Why pick the y coordinate? It's the sine on the unit circle. All right, now it's your algebra. 6 radical 3 over 2. Go ahead and reduce it. You end up with 3 radical 3. Questions? All right, here we go to 2. We got a terminal side in the third quadrant. I give you cosine. What's sine going to be? Well, Megan, ready? Right off the bat, I want to try, hey, everyone else too, I want to try to eliminate half of those multiple choices. And we should be able to. We're finding the value of not cosine, Megan, but sine. And what quadrant are we in? Third quadrant, right? Third quadrant value of sine. Positive or negative? All students. Negative, right? So we can eliminate 3 and 4. John Carlino. How you doing? Yep, no problem. Yep. Okay, you got it. Yep, bye-bye. Virginia, Mr. Carlton wants to see you. You can go right now. Yeah, he said right now. Everybody good on how I eliminated those 2 positive answers? Why did I? Because what do you know? We're in the third quadrant, and what do you know about sine? It is negative. All right, so I know it's got to be choices 1 or 2. How can I find out what the sine is? What did we just go over? Reagan just asked the homework question. If I'm given cosine and I want to find sine, what identity can I use? What's it called, Isabella? You're up. Pythagorean identity. Sine theta squared plus cosine theta squared equals 1. Ethan, where am I plugging that negative 0.96 in for? Cosine, yep. I'll let you guys go to work right now. Go ahead and finish it for me. Go ahead and find this value of sine now. Brooke, let me know what you get when you're done. Negative. Yep, 0.28, you got it. Can we get to that step? Square it, subtract it by moving it over, taking the square root. And again, why is it negative? Matt, why is it negative again? Because remember, you would get plus or minus 0.28 out, but why am I choosing the negative value over the positive value? Sine in quadrant 3 is negative. Questions? Guys, can we get to that point, yes or no, algebraically? 0.28? Okay. All right, let's go. Okay, this is where, here we are. This is where we need to be here at this point in the unit. Determine the following values and exact. All right, timeout. I did go over this on Thursday before I left. Exact. What do I not want? Decimals. I want fractions and radicals. I do not want sloppy decimals that you get out of your calculator. So here we go. Sine of 570. I need you to first figure out if that's going to be positive or negative. So what quadrant am I in for 570? Here we go. I go all the way around. I'm back at 360. What's next after 360? 4, 50. Not there yet. Then I go to 540. Not there yet. Then I go to 630. I think I got a quadrant now. Annika, what quadrant is 570 in? Third, and ready, I'm going to ask you a follow-up question. What do you know about sine in the third quadrant? It's negative. So at least I know right now I'm going to have a negative answer because sine is negative in the third quadrant. Now, how am I going to find out what the actual answer is versus not just positive and negative? Find the reference angle. What's the reference angle for 570 right now? What is my reference angle going to be? So this angle right here. 5 70. What would be that little angle right there? Alex, what is it? 30 degrees. If you guys are wondering, I know a lot of you are like, how the heck did he get that? Here's how I got it. I know that, hey, from here to here is 570, and from here to here is 540. So the piece left over was 570 minus 540. Oh, 30 degrees. Where's that point on the unit circle? Patrick, you're up. Where's that point on the unit circle? 30 degrees. What point would it intersect on the unit circle? 30 degrees. Yep. Great job. Didn't even have to look back. I'm proud. Everyone agrees? So negative sine, the reference angle was 30. These two are the exact same things. Take a look. Sine of 570. Where'd that negative come from again? Where'd this negative come from? Third quadrant, sine's negative. Where'd that 30 come from? That's my reference angle. Okay. Let's finish this off now. Cooper, you're up. If I'm looking for sine, which coordinate do I want? The y value, so it's going to be negative 1/2. Take a look at what we just did up there. If there's issues. Any questions? Negative 1/2. Okay, here we go. Next one, cosine 135. Who's up here? Reagan, what quadrant am I in? And it's, what do I know about cosine in the second quadrant? Positive or negative? Great job. So at least we got down that this is negative cosine of something. What's the reference angle for 135? Reference angle, 135. That's what I'm going to plug in next. Emily, any way I could find the reference angle for 135? Which gives me? Guys, do you hear the numbers you're telling me? 30, 45, those should all be the classic ones on the unit circle. 45. Anna, do you remember the point on the unit circle where 45 goes through? Vinny, well, this is not really a great question, but which one do I want? X value, because it's cosine, and you can't really get it wrong, right? So negative radical 2/2. Seeing how that worked? We got one more, a little tricky though. Ooh, this is in radians, okay. Emma, you remember what pi over 2 was? $90, and I'm going to multiply it by 3, so, okay, that's 270. Whoa, where's 270? That's on the line, right? Not in a quadrant. Anybody for huge bonus points? If it lies on the line, what type of angle I call that? Oh, look at here, quadrantal angle. Yeah, not bad. All right, so it's 270. So I don't have to ask if it's positive or negative, but I do want to know the point on the unit circle where 270 goes through. Let's go back over here, Matt. Unit circle goes through 270 at what point? Nice job, stud. 0, -1. Which coordinate do I want, Brooke? Why? Because it's the x coordinate. Because it's cosine, I want the x coordinate. There you go. Cosine of 270, 0. All right. You guys have any questions for me? That's everything we've done so far. This is where we need to be right now, is right here. Because in the next 15 minutes, I'm going to go over something else. Anything, guys, ask away, anything. We did Pythagorean identity. We did, is it positive or negative? In the certain quadrant, find the reference angle, and then use the unit circle. Any questions? Okay, what's going to happen right now in the next 15 minutes? We're getting away from the unit circle. What happens if it's not on the unit circle and I'm still going to, I'm still going to ask for cosine and sine, but we're not on the unit circle. So how do I deal with that other than just cry? Okay, take a look down below. Here was my unit circle. here's the circle we're on right now. And it doesn't really matter that you know it's x squared plus y squared equals 169, the equation. But I want to make it clear we are not on the unit circle anymore. But I do know point A is at 12.5. 12.5. And I'm still asking for sine and cosine. But here's what you can't do anymore. All right? You can't say, oh, hey, you're looking for sine, Mr. Carlino. I'll just pick off the y value. It's 5. No, that only works if we're working where? Unit circle. Does everyone see that? That we're in a dilemma right now. You can't just give me the y coordinate. And also, I probably should have mentioned this, and I'll make sure I get better at it. The y values only go up to what on the unit circle? 1 and go down to -1. You should, ready? You should never tell me sine is anything bigger than 1. Right? Look at, hey, if you look at all the y values, what's the biggest it gets? 1. So if you tell me, oh, the sine is equal to 2, baloney. Oh, baloney. It never goes above 1, and it never goes below -1. Okay? Sorry. So there's no way on this example it can be equal to 5. So how in the heck are we going to do this? Do I know how we're going to do it? We're going to get our good old buddy, the forgotten one, SOHCAHTOA back. How are we going to use SOHCAHTOA? Well, Lucas, do you remember what type of triangle I need to use SOHCAHTOA? You're darn right, and that's what I'm going to make out of that diagram right now. I'm going to make a right triangle. So from point A, draw a vertical line down. Right triangle. Woo! And the angle we're going to use is always the reference angle. How's that help? I don't even know any of the side lengths. Baloney. 12.5. That point's 12.5. 12 on the x, 5 on the y. You should be able to fill in some values now. How long is it here, the horizontal distance? 12, because it's got an x coordinate of 12, right? You went over 12 and boom, up 5. So I'm going to make a right triangle out of these now when I'm not on the unit circle. Ethan, what's sine equal to according to our good boy SOHCAHTOA? What is opposite my reference angle? 5 over hypotenuse. Ah, shoot, we don't have it. Can I find it? How? It's a right triangle, you know, 2 sides. You can do Pythag. There we go. I can use Pythag to find the hypotenuse. 5 squared plus 12 squared equals c squared. And I'm just going to give you a little tip at the end, but we'll keep going. You do get 169 when you add the 2 together. C squared. Take the square root, you end up with, oh, hypotenuse is 13. So the sine is 5/13. Cosine now? Here we go, Megan. What was cosine equal to according to SOHCAHTOA? Okay, what's adjacent now to my reference angle? 12 and the hypotenuse I just found? And I don't know, maybe if you guys start picking this up or not to save you guys some time. 5, 12, 13, that's a common Pythagorean. It's called a triple. All right. Anybody know the other common one? 3, 4. No? 3, 4, 5. That's another common one, so you don't have to do Pythag every time, but you can do that. You guys see what we're doing now? Making a right, because we're not on the unit circle, we're going to make a right triangle and use SOHCAHTOA now. All right. Definitely 1 doesn't make you great. Here you go. Go ahead and graph 3, 4 here. Go ahead and graph 3, 4. That's where the terminal side goes through. You guys know what a terminal side is. Here we go. 3, 4. Okay, not on the unit circle. So I'm going to have to make a right triangle. And guys, when you make a right triangle, make sure you make it with the x-axis, because remember, I need a reference angle. Did you just make it with the y-axis? Make it with the x-axis, because remember, you need a reference angle. Reference angles with the x, not the y. Okay, Isabella, you're up. 2 sides I can label. What's the bottom side going to be? 3, because that's the x-coordinate. What about the vertical side? 4. And this is what I was just talking about, guys. 3, 4, 5. If you want to remember it, that's fine, but you can always use Pythag. If you're nervous, sweating uncontrollably, that's fine. Okay, let's work here. Vinny, we'll go to you. Sine is equal to? Yep. What's opposite theta? Over hypotenuse. Nice job. Emma, I want to take care of cosine now. Adjacent 3, hypotenuse 5. It's not too bad, huh, young ones? Except there's a third piece here that I threw in that I did not throw in last problem. Find sine, find cosine, but also find, there's no tangent here. That word does not come up. Maybe tomorrow if you're here. Find the angle theta. So what is this angle measurement up there? Okay, how many degrees in that angle? And we have done this unit. We have done it. Here's a hint right now. What's so special we have to go on the calculator? What is so special anytime you need to find an angle from a triangle? Anybody remember what we go on the calculator? Going? Anybody? Inverse. There we go. Yep. Now some of you are inverse of what? You pick. What do you want to do? Sine or cosine? It's your call. Class decision. Matt, speak for the class. Sure. So we're going inverse of sine. But now, be careful now. What fraction do you plug in? 4/5. Yep. Hey, you guys want to be a little saucy and go cosine, inverse of cosine? Go ahead. Let's see if we come up with the same answer. All right, if you want to get a little saucy. And it does say round to the nearest degree. Who's up? Cooper, you're up. What do you end up getting here? Or doesn't matter, sine or cosine. We're all going to come up with the same value. Sine, we got 53. Doesn't matter which one you use. As long as you plug in the correct fraction with it, doesn't matter. All right, if we're not on the unit circle, because we got one more here as a class. Nothing's changing, except we're in a different quadrant now. Okay, 6, -5. Go ahead, 6, -5. 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. There it is. Let me just at least see you graph the terminal side. Do a correct triangle now. Label the triangle correctly. And then we'll get back together. Make sure you have a reference angle with the x-axis, not the y. What'd you guys put on the horizontal side? 6, that's what I put too. And then on the vertical side, whoa, kiddos, hold on. We're not in quadrant 1 like the last problem. What do you know about all the y values down here? All the y values are negative, right? So make sure that's negative. I do not know this triple. I'm sorry, everybody. I have no idea what 6, 5 something gives you, so I got to rely on the Pythagorean theorem myself. Reagan, you're going to be up when you let your classmates know what the hypotenuse is going to be. And you can just leave it underneath the radical. That's it. Okay, here we go. Emily, ready? Sine is opposite over. Okay, so using your triangle, what's opposite? Okay, and what is the hypotenuse we just found? Okay, you know my words next, self-respect. Why self-respect, Anna? What can I not have up here? What's wrong with my answer right now? So what do you want me to multiply top and bottom by to get rid of it? There you go. So the sine's going to be -5 radical 61 over 61. Hey, real quickly. Easy over there. Vinny, do you know why that came out to be negative? Even before setting up a triangle, did you know how I was going to know that answer would be negative? Fourth quadrant, and what do you know about sine in the fourth quadrant? Oh, look how this all relates. It's beautiful. So without knowing anything about the triangle, guess what? Cosine, this should be what in the fourth quadrant? Positive. Let's find out. Adjacent over hypotenuse. Emma, what's adjacent here? 6. Hypotenuse. All right. Self-respect. Multiply top and bottom by the square root of 61. And it ends up being 6 square root of 61 over 61. Positive, shockingly, positive. All right, we are going to end this sucker with a bang right now. Because what's the third part still? Find the angle, right? Okay. Last time I said, hey, choose anything you want, which is still true. My recommendation to try to make your life easier when you find the angle, try to use the positive one. Okay, try to use the positive angle or the positive value, which in this case would be cosine for us. All right, try to use the one that came out to, if neither of them came out to be positive, all right, you're just going to have to pick one and deal with it. All right, but just to make life easier, find the inverse of the positive value, which would have been cosine. So thank goodness a lot of you guys have fraction templates. So go ahead, inverse cosine 6 radical 61 over 61. And I'm going to have an issue with your answer. And some of you are probably like, why? Why do you have an issue with my answer? What are you guys getting for an answer? 40, right? So what the heck's wrong with that? Who cares? I rounded it correctly. Thanks a lot. See you later. Good class. We got an issue. Ladies, gentlemen, what quadrant have I been working in all problem long? Quadrant 4. 40 degrees is in quadrant 4? I don't think so. We got a problem, don't we? Everyone see why 40 is not going to cut it. It's in quadrant 4, not quadrant 1. But hey, we're almost there. What did your calculator find by finding 40? It found the reference angle. Yeah, that's 40 right here. That angle, the reference angle is 40. So if you wanted to find what the actual angle in quadrant 4 was, we've done that before. We have the ability to do that. If the reference angle turned out to be 40, how can you find the actual angle now? What are the numbers I need to crunch here? 360 and 40. And what do I need to do with them? Subtract them. So the angle in the fourth quadrant should have been 320. Please watch out for that. Trying out the assignment tonight. Make sure you get an angle in the quadrant. Nice job. Got to try some of those. Got to try some of those.